Hello guys, in this video I'm going to show you how to solve palindrome linked list problem. So given the head of a singular linked list, write a method to check if the linked list is a palindrome or not. Right. So what is the palindrome? Palindrome is a sequence. It can be strings or an array or a linked list. Right. Okay. So palindrome is a sequence that reads the same forward as backward. So for example, we have A, B, C, B, A. So if we go backward, it would be A, B, C, B, A, right? Same as if we go forward. Or another example, uh, A, B, C, C, B, A, right? The same if we go this way, A, B, C, C, B, A. Here the case, the total items are odd, right? But here's we have even numbers of items. So if it is a string, we have two ways, right? It's a pretty easy problem. If it's a string, we can check, we can iterate using two pointer, iterate from two ends, go all the way to the middle node, right? Middle characters. And if everything's if all two pairs are equal, it means it is a palindrome, right? That's one way. The other way we can reverse is we can reverse this sequence, right? And compare the reverse with the original one. If it is equal, it is a palindrome string, right? So how about the linked list? What is the difference here? As you can see, linked list is a data structure that we can only iterate forward, right? So here we are given the head of the linked list, right? So we can only go this way from left to right, 1 to 2, 2 to 3, right? But we cannot go the from the end, from the tail of the linked list backward to 2 to 3, right? So that the characteristics of a linked list, right? So so in order to get around these issues, um, one simple idea is to just reverse the second half of the linked list, right? Then we're gonna do the same as a strings. Iterate from two ends, go all the way to the middle. But the one requirements here, which is missing here, but there's one constraint that we cannot modify. The we cannot, like, after checking, we should have the linked list same as the original. So probably after messing up with the second half of the linked list, we want to reverse it again. So simple idea. Let's run into coding now, right? Mm, we have the head, right? So in order to reverse the second half of the linked list, we need to first find the middle node first, right? So that we can start from the middle node. We can start from here and reverse all the way until the end, right? Uh, Here we, as you can see, there are two cases here. If the number of nodes are odd, then the middle node is, in this case 3, right, is the middle node, right? But if the number of nodes is even, we're gonna take the one on the left, right? Then we have two middle nodes, right? We're gonna take the one on the left. So here I'm gonna first find the middle node. Okay. Uh, then next step is to reverse second half of the list, which means all the way from the middle node. Okay, so after the reverse, I'm gonna check palindrome dromicity palindromicity iterate by iterating from two ends, right? So the last step is uh, to re-reverse, right? Second half of linked list, return, and finally return result. Okay, that's the some bullet points we want to implement. So find the middle node. This this simple problem we've solved previously, right? So let's abstract out into a functions so that we avoid polluting our main functions. So we have middle node is returned from the return from the function find middle, right? This one will take in the head node, right? So the next step is to reverse the second half of the linked list, right? So again, I'm abstract it out into a in functions. So reverse uh, reverse from which node? From the middle node. I'm gonna reverse from the middle node. Then do we need to return something here? We need to get access to the last node, right? Because the next step is to iterate from two ends, right? One end is the head and the other end is a tail. Right, so let's say this will return the tails, right? The tail, which is the the tail, the original tail will become the head of the new sublet of the sublets that is reverse. Okay, so gonna start from head and tail. Okay, check palindromicity. Okay, so mm, what is the check here? The check here might be so because we don't want to, we must initialize two working pointers, right? So let's say left is head, right? And right is tail, and wanna stop. Wanna keep iterating uh, as long as what? As long as maybe um, so here is a go if this guy let go all the way to C, right? Go all the way to the C. Next step, it will cross each other. So we cannot check equal, right? It will not meet in one point. But we know the middle, right? We know the middle here. We keep track the middle here. So as long as the left is different than middle. So for example here, the left is so if two pointers are here, left at C and right at C, we probably don't want to stop there. We want to do the last check. So here it should be right, given the middle, right? So after these comparisons, we're gonna keep iterating. Right will be this C, and left will be this C. So it is when the right is equal to middle. So wanna exit the loop. If it is middle here, so when the last iterations, it is here, left is B and right B. So next is the mid C is when right equal to middle on the exit, right? So in case the number of nodes is odd, we we don't need to check the middle one, right? So as long as here, right? So we need to store the result. Initialize is true. So if there's any pair that is if left any pair that the value is different than right, well, I'm gonna reassign the result to false, so it's not palindromic, and I'm gonna stop the loop right there. What's wrong here? So I'm gonna return the result. Okay, so after checking palindromic, I'm gonna reverse the second half of the linked list by this time I'm gonna pass in the tail here, right? We want to start reversing from the tail. all the way to the uh, middle, right? All the way to middle. Mm, so the questions here might be, uh, what is will we can we stop reversing at the middle node? So let's see this example. So for example here, 1, 2, 2, 2, 3, 2. Here the middle node, right? Wanna start reversing from here. So because I start reversing from this tree, then this tree now gonna point to no. Let's visualize it a little bit here. This tree will point to no. Okay, because we start reversing from here, this will point to no. Okay, and everything after will will point backward to 2 here, to 1 here, right? So after we reverse, we wanna check, go all the way as long as the right working pointer is different than this one, right? So this here is, so it will finish when right is this one and left is this one, right? So that we can check all pairs in this list. But after that, I wanna reverse, right? Re-reverse, starting from 1, which is a tail here, all the way until the node, right? So the last node that is reversed is here, right? For example, we start from 1, point back here. Okay, go to 2. No, sorry, from 1 it will point to node. It's the first node. 2 it will point to 1. 3 it will point back to 2, and 3 here is the last node. It will point back to 3 here. So it will be reversed, and we have the our original sublist, original linked list, right? Same as the original linked list. After two rounds of reversing. Okay, let's implement the two functions. We have first the find middle. We take in the head. For this one, I'm gonna use find middle simple. Use 2 pointers. I use slow fast pointers. Let's slow is head and fast is heads also. So as long as we have fast, and fast.next is not no, and fast.next is not no. Get into loop. I'm gonna move the slow one step, slow.next, and fast two step, fast.next.next. Okay. So we exit when we don't have the fast, or one of these is false, right? So I'm gonna return the slow. So it will stop when fast is at the end of the linked list, and slow is the middle. So I'll return slow as a middle node. The next functions we need to implement here is the reverse one. Reverse, take in the let's say the head, right? Not same the head here, but the node that where we start. So reversing. So for reversing, we need the previous node, right? Initially it's no. Okay, and we also need the current is a working pointer. Initially is head. So as long as the current is not null, we get into the iterations, get into the loop. At one iterations, for each iteration, I want to point the current node to the previous node. But before pointing, but by pointing the next subcurrent node to the previous, I will lose connection to the next node. So it means I need to save it first. Next node is current.next, right? Update. Next node. Okay. So after point the current node to the previous, I will update current and next. In previous, before the next iterations, right? So the previous will be the current, right? And the current will be the node we save here. Current is next node. I think okay. I think that is it for this one. Let's on the test just two no three slow fast pointer. Problem 5, I guess. Okay, let's see how it goes. Come on. Whoops. Cannot read file of undefined. Oh, come on. We need to return something here, right? So we exit when current is null, and the last node is actually the previous, so we need to return previous. Run it again. Forgot.